Direct variation in word problems might say directly proportional to, varies directly as. It's all about setting up the variation equation. So this is another way of thinking about proportionality. Let's take a look at this very first problem. If x varies directly as y, and x equals 18 when y equals 6, find x when y equals 7. So right off the bat, if x varies directly as y, we need to know how to translate this. X varies directly as y is almost self-explanatory. X is x, y is y, but we can't just put equals. When we see a variation statement, we need to have something about our constant of proportionality k. So it's not just equals, it's equals k. X varies directly as equals k, and for direct, we multiply y. So why do we always have to set it up with this statement? Why do we need to have this k in here? Well, we're going to use the next bit of information, x equals 18 when y equals 6, to solve for k. So if x is 18 and y is 6, divide both sides by 6 to solve for k. Here, k equals 3. So now instead of x equals ky, we have x equals 3y. And we use this now to finish the problem off. Find x when y equals 7. So plug 7 in for y. And we get that x is 21. Let's look at another one. Number 2, I have z varies directly as x squared. So let's translate that. Z varies directly as x squared. So direct variation equals k, and then we keep in the same line, keep multiplying. They tell us if z equals 36 when x equals 3. Okay, so we stop there to solve for k. Plug in 36. Plug in 3 for x. So 36 is 9k. Divide both sides by 9. We get k equals 4. So z equals 4x squared. We take that value for k, plug it right back in to get our direct variation equation. So there is proportionality at work, but we solve it using the variation equation. The final part of this number 2 says, find z when x equals 5. Find z when x equals 5. So 5 squared is 25, order of operations. We get z equals 100. Now, if direct variation is multiplying after the k, inverse variation is going to be dividing by the k. And number 3 here, z varies inversely as w, and z equals 20 when w equals 0.8 Find z when w equals 10. We're going to break it down the same way. First, a translation. Z varies inversely. So instead of multiplying after k, we're going to divide after k. Inversely as w. And z equals 20 when w equals 0.8. And then we're going to find z when w equals 10. So plug in what we know. Z is 20. W is 0.8. To solve for k, we would multiply both sides by 0.8. 20 times 0.8 is 16. So k is 16. Plug that back in. Z equals 16 over w. So what's z when w is 10? It would be 16 over 10. 16 divided by 10 is 1.6. Number 4. Z varies inversely as w squared. Z equals 10 when w equals 4. Find z when w equals 3. So first, z varies inversely as w squared. Z varies inversely, divide, as w squared. Don't forget the square. We're told z equals 10 when w equals 4. Plug in 10 equals k over 4 squared, 16. To solve for k, multiply both sides by 16. That's k equals 160. Plug that back in. Z equals 160 over w squared. And then the rest of the problem said, find z when w equals 3. 3 squared is 9. We have 160 over 9. We're told to simplify our answer. That doesn't divide evenly. We can just make 160 over 9 the answer. So in 5, y varies jointly as s and v squared. Y varies jointly as s and v squared. So joint variation is just more than 1. We can also have combined variation. And combined would be if we have direct and inverse. If we have multiplying stuff and dividing stuff. So the numbers they give us, when s equals 7 and v equals 5, y equals 700, we're going to want to find y when s is 11 and v is 9. So for joint variation problems, they have to give us more information. Because if we're looking for one thing, they need to give us everything else. First, we use all 3 points they give us, data values, to plug in and solve for k. So y is 700, k is unknown, s is 7, v is 5, so v squared is 25. 7 times 25 is 175. So 700 equals 175k. 700 divided by 175 is 4. So 4 is k. Plug that back in. Y equals 4sv squared. So what is y when s is 11 and v is 9? V squared would be 81. 4 times 11 times 81. Whew. Y is 3,564. The weight m of an object on the moon varies directly as its weight e on Earth. A person who weighs 153.24 pounds on Earth weighs 26.05 pounds on the moon. How much would a 231.76 pound person weigh on the moon? So if we read that first sentence, the weight m varies directly as the weight e. M varies directly as E. M varies directly as E. A person who weighs 153.24 pounds on Earth, so when E equals 153.24, they weigh on the moon 26.05 pounds. So M is 26.05. Then we want to know what's M, what's the moon weight of a person with an Earth weight of 231.76. So what's M when E is 231.76? So we pulled this out of the word problem. And we do it just like we did before. Plug in what we have so we can solve for K. 26.05 equals K times 153.24. Divide both sides by 153.24. So 26.05 divided by 153.24 is 0.16999. I think we can call that 0.17 without worrying about a rounding error, no problem. So, M equals K, 0.17 times E. What is M when E is 231.76? 0.17 times 231.76 is, and it tells us here to round to the nearest tenth, 39.399. That's 39.4. The volume of a can is directly proportional to the height of the can. If the volume of the can is 400 cubic centimeters when the height is 14.62 centimeters, find the volume to the nearest whole number of a can with height 16.92 centimeters. So pull out what we need. First, the first sentence tells us the volume of a can is directly proportional to the height of a can. Let's call volume V and height H. V is directly proportional to H. V is directly proportional to H. If the volume is 400 when the height is 14.62, find the volume when the height is 16.92. So there's the information. Nothing's changing with how we do it, though. V is 400, K times 14.62. Divide both sides by 14.62. 400 divided by 14.62 is 27.3597. So like 27.36. Plug that in for K. V equals 27.36. H. What is V when H is 16.92? So we have to do 27.36 times 16.92. We want to round this. It says do not round until the final answer, then round to the nearest whole number as needed. 462.93, that's going to be 463 cubic centimeters. Number 9. Over a specified distance, rate varies inversely with time. Let's get that part down. Rate varies inversely with time. If a car on a test track goes a certain distance in 1/5 minute at 175 miles per hour, so time is 1/5 of a minute, the rate is 175 miles per hour. What rate is needed to go the same distance in 2/3 minute? What will be the rate if the time is 2/3? So plug in what we know. R equals K over 1/5. Oh boy. To undo dividing by 1/5, we would multiply both sides by 1/5. So 1/5 R equals K. And actually, even though I can solve it that way, we saw that working with literal equations, I forgot to plug in R. R is 175. So 175 equals K over 1/5. Dividing by 1/5, undoing that is multiplying both sides by 1/5. So we would have ended up in the same spot anyway. 1/5 times 175 is the same as 175 divided by 5. Which is 35. So K is 35. R equals 35 over T. What is R when T is 2/3? Again, since we're dividing by 2/3 and we want to undo that, multiplying both sides by 2/3 will do that. 2/3 R equals 35. Unnecessary, unless you need to see that we're multiplying by 3/2. Fractions, am I right? So this is 105 over 2. Which is 52.5. Since we were dealing with fractions the whole time, instead of 0.5, we really should say 52.5. The current in a simple electrical circuit is inversely proportional to the resistance. So the current is inversely proportional to the resistance. C is inversely proportional to R. C is inversely proportional to R. If the current is 40 amps when the resistance is 3, so C equals 40 when R is 3. Find the current, C equals what? When the resistance is 7.2 ohms, when R is 7.2. Okay, same problem as always. R is 3. C is 40. Multiply both sides by 3 to get K. K is 120. So C equals 120 over R. What is C when R is 7.2? 120 divided by 7.2 is 16.666666, which we know is 2/3. So 16 2/3 amps. The amount of time it takes a swimmer to swim a race varies inversely with her average speed. A swimmer finishes a race in 375 seconds with an average speed of 4 feet per second. Find the average speed of the swimmer if it takes 500 seconds to finish the race. Okay, so the amount of time varies inversely with speed. Time varies inversely with speed. A swimmer finishes in 375 seconds. So when t is 375, the speed is 4 feet per second. We want to find the speed when the time is 500. So another word problem, but we pull out the same information. So 375 equals k over 4. Multiply both sides by 4. We get that k is 1500. Oh. Just plugging in k. T equals 1500 over S. What is S when t is 500? Oh, S. Do you also have difficulties writing 8s when you're trying to write S's in math because math is numbers? Jeez. Okay, so we have t equals 1500 over S. We want to know when t is 500, what is S? Now, this is a little bit different than what we've done before, because now we're solving for something that's still out here. So first of all, the S is on the bottom. Let's multiply both sides by S. 500S equals 1500, and now we can divide both sides by 500. S equals 3. 3 feet per second. Now, again, that was different because normally those ones we were doing, the thing we would plug in would be on the right side, and we'd just do the math. But here, it was t that we had, and we were looking for S. Let's do one more. The distance that an object falls when dropped varies directly with the square of the amount of time since dropped. Distance varies directly with the square of time. D equals kt squared. An object falls 88.2 meters, so D is 88.2, in 3 seconds when T is 3. Find the distance. What is D? It falls in 5 seconds when T equals 5. So 88.2 equals K times T squared. T is 3, so times 9. 88.2 divided by 9 is 9.8. That's a physics number. Putting it back in, D equals 9.8 T squared. We want to find the distance when T is 5. If T is 5, that means T squared is 25, and 9.8 times 25 is 245. 1,245 meters.
The body mass index, BMI, of an individual varies directly as the weight of the individual and inversely as the square of the height of the individual. The body mass index for a 156-pound person who is 65 inches tall is 25.96. Determine the BMI for an individual who is 72 inches tall and 175 pounds. Round to 2 decimal places. So what's important is that very first sentence. We need to write it out using K as a constant of variation, multiplying by things that are directly proportional, direct variation, dividing by things that are inversely proportional, inverse variation. So the body mass index, BMI, of an individual varies directly, so multiply by the K, directly as the weight of the individual and inversely as the square of the height of the individual. So the body mass index is varying directly as the weight and inversely as the square of the height. Then we're told the body mass index for a 156-pound person, so when W is 156, who is 65 inches tall, so 65 squared, square of the height, is 25.96. If we square 65, we get 4,225. So 156K over 4225 is 25.96. If I multiply both sides by 4225, 25.96. I get 109,681 is equal to 156K. And then if I divide both sides by 156, I get for K, 703.08. So BMI is 703.08 W over H squared. All of that to solve for K, to plug it into the equation. This is now the equation we're going to use to determine the BMI for an individual who is 72 inches tall, that's the height, and 175 pounds, that's the weight. Remember, we're going to round our answer to 2 decimal places. That's why I did 2 decimal places here. So W is 175. Height is 72. The BMI is 703.08 times 175 over 72 squared. $123,039 over 5,184. Gives me a BMI of 23.73.